Welcome everyone to the 2025 Online DOE Summit. We are excited to present this latest entry in our conference series for our 40th anniversary. That's right, Staties was founded in 1985, which makes us 40 this year. In honor of that anniversary, we have 8 wonderful presenters this week, starting with Andrew McPherson from Prism Training and Consultancy. We are excited to have him here to present on designing optimal espressos. So with no further ado, Andrew, please take it away.
Thank you very much, and thank you very much for hosting this, and it's a great honour to be delivering the first talk of this week. A lot of good things on the schedule, so we'll be tuning in throughout. So good afternoon, good morning, everybody. Welcome to the DOE conference. We're going to start off with some fairly basics. First of all, what is DOE and what does it mean to you? A lot of people would see the letters DOE and assume it stands for Designer Experiments, of course. But what I'm going to try and persuade you over the next 45 minutes or so is that actually there's an alternative interpretation of that, which is just as interesting. And that is all about developing optimal espressos. So my talk is very much a very silly application of some useful tools. You know, we all know how brilliant DOE is. I've taken a slightly different take on this, which I hope you'll find interesting and enjoyable. So let's dive in. Over the course of the next 45 minutes or so, what I want to do is obviously go through some basics. So I'll introduce myself and my company to you. I will spend quite a bit of time exploring a really important part of DOE, which I don't often get the chance to look at, and that is what goes in before we get into the DOE software. How do we plan our experiments? How do we work out which factors we want to look at? All that kind of interesting scientific stuff, which as a DOE trainer, I'm not usually privy to. So I'm going to enjoy doing that. We'll then talk about how we're going to set up a design to explore and optimize our espressos. I'll tell you briefly how I carried out the study, and then we'll take a look at the analysis at the end of today's talk. We'll draw some conclusions, hopefully all of which will be useful, and hopefully it'll be a nice, interesting start to a good week of DOE presentations. So to start off with a quick introduction about Prism Training and Consultancy. We are an independent statistical group. We're based in Cambridge in the UK. We offer statistical training, consultancy, and software sales. We're the Staties reseller for the UK and Ireland and have been for 14 years now. So we very much enjoy working with the folks at Staties. We have a small team of people, and we were founded in 2000. So much like Staties, we are celebrating a big birthday this year. This year marks our 25th anniversary. So we haven't quite caught up with Staties yet. They're 40, but hopefully we will do so. A little bit about myself. My name is Andrew McPherson. I've been with the company for 20 years now, initially as a consultant, then I was an employee. I've been managing it for about 10 years now. And in the early days of my work with the company, I was mainly involved with data management and developing software tools. I have many responsibilities at the moment. The one I enjoy most is delivering training in design of experiments. What I always tell people at the start of a DOE course is that I'm not actually a statistician. I'm not here to try and dazzle you with statistical theory. What I want to do with my interest in software and some interest in statistics, but with the delegates' scientific expertise, is kind of exploit that really interesting intersection between the statistics, the software, and the science. As I say, I'm not a proper statistician, but I have been hanging around them for quite a while now. I'm not a scientist, as we will see very clearly as we go through this talk. But it got me thinking as I was pulling together these slides that actually maybe some science and statistics is within my genes somewhere. Because I was just thinking back about where my sort of motivation came from for this talk, and thinking about it. My parents, when they were working, they were both statisticians. They're both retired now, but they were working statisticians for a good chunk of their careers. So that's kind of the statistics side of things. I feel I've got that in my blood. What about the science, though? Well, I was actually talking to my daughter about this recently, and we were looking back through our family history, and my great-grandfather was a prominent entomologist by the name of Charles Henry Tyler Townsend, and he was very interested in the taxonomy of flies. I mean, whatever floats your boat, I guess, but he was very prolific. He categorized over 3,000 different types of flies and did some important work in identifying how diseases could be carried via insects. Unfortunately, it's not all good news, though. His work has been somewhat criticised, and he's been called things like eccentric. And perhaps most cuttingly of all, perhaps his work has done more to retard taxonomy than advance it. So I have got science in my blood too, but it sounds like I've got sort of bad science baked into my genes. So I apologise in advance for what's about to follow. Why am I looking at espressos? Why am I trying to apply this statistics and this scientific interest to something as trivial as making coffee? Well, the honest reason is, we're a consultancy group. We don't have any of our own data. What we do is we work with our customers to work on their data with them and help them to understand it better. Therefore, I can't show you our customers' data because it's not ours to share. So we're going to have to make up some data of our own for this talk. And I figured that coffee, it's a familiar subject to many people. So I imagine a lot of people watching this will be coffee drinkers themselves. You may gasp in horror when you see how I make coffee compared to how you do it. But I hope there'll be some areas of interest for all you good folks. Thinking about coffee and applying DOE to it, I got thinking about this a while ago because my coffee machine's got lots of buttons and dials and things that you can play with, so it kind of lends itself nicely to experimentation. And what I typically found is that each time I bought a new type of coffee, I would spend a few days just kind of a bit trial and error, making a few bad coffees before I eventually stumbled across the right settings for that particular new coffee type that I was trying. And every time I did this, I knew it wasn't right. I knew as a DOE trainer, I should be doing better than this. I should be looking at this systematically and really making sense, developing an understanding of what's going on here so that I can optimize my equipment much more easily and efficiently to make the most of any batches of coffee that I'm trying. So I finally figured it's time to bite the bullet. I've been thinking about doing this sort of project to optimize my coffee for a while, and when Statis asked if we wanted to present this talk, I figured it was the ideal opportunity to dive in. I should stress that in this talk I'm focusing on espressos, not filter coffee, not cappuccinos or anything like that. Purely, selfishly, I don't like milky coffee. I only like black coffee. So I'm doing my talk on my preferred type of coffee, which is espresso. As I go through this talk, I will be using the words coffee and espresso interchangeably. I hope that doesn't cause any confusion or irritation. But as we go through, we will explore these things and see how we can make the perfect cup. Now, as I mentioned before, the thing that I found particularly interesting about pulling these slides together was this bit, setting up the study. How do I work out what I need to look at? What do I need to consider in order to make my study successful? When you're considering setting up any DOE study, the first thing to do is not to fire up Design Expert. The first thing to do is to spend some time applying your expertise, thinking about which factors should I explore, which ranges do I think it would be interesting to look at for my selected factors, which responses do I need to measure to assess whether my process, my assay, my formulation is doing what it needs to do. So before we start playing with software, we need to actually use our brains and think about what it is we want to look at. Those of you who apply DOE routinely, you have the advantage on me because you're applying DOE within your area of expertise. Unfortunately, when it comes to making coffees, I don't really know what I'm doing. I just put the coffee in and then the coffee comes out a few minutes later and I try it and hopefully it's okay. So what I had to do for this study was spend quite a bit of time going online and reading up on coffee to try and develop some expertise so that I knew roughly where to start my study from. I did a lot of reading, a lot of Googling, a lot of searching around online. And one of the first things I came across, of course, is the talk that Statis themselves, the study that Statis themselves did back in 2016. So this is available on their website if you want to take a look at this. Very interesting design. They use a split plot combined design, which allowed them to vary the proportions of different types of coffee bean, as well as changing things like grinder settings and amounts of coffee being used. So it's a really good study. And of course, there's a really good photo to go with it. A very handsome bunch of gents there, obviously sampling some excellent coffees. So I'm well aware that there's a bit of overlap between what I'm doing today and what's been done previously by Statis. So I've tried to make sure that I'm coming at this from a different perspective. I don't want to kind of do any overlap and tread on any toes. So I'm going to be looking at some slightly different sorts of questions to those that were addressed in the previous study. As well as the Statis resource, there's lots of other useful resources that I found online that I could read up and learn as much as I could about making coffees. The most useful resource, genuinely, is finding somewhere local. I found a coffee roasters in Cambridge, just over the road from our office, really friendly people there. So I was able to actually sit and chat to experts and pick their brains so that I could make my coffee better. They could advise me on what sorts of things I should be doing to make the best espressos. So the value of expertise can really not be overstated. And I was sucking up from anywhere I could. What did I learn from all this research? Well, it seems that the key to making a good espresso is the extraction. And basically, this is how much coffee are we pulling out from our ground coffee into the drink that we end up consuming. And there is a long established theory that says under-extracted coffee is sour, over-extracted coffee is bitter. So the idea is we want to get somewhere there in the sweet spot in the middle where it's not too sour, not too bitter. We want it just right. So extraction is going to be absolutely critical if we want to get the coffee tasting good. Also related to that, there are different extraction ratios that we can look to make our coffee to. Classic espresso has a ratio of 1 to 2. That is, we use 18 grams of ground coffee to make a 36-gram drink. And that ratio is what most people consider to be about right for an espresso, but it's open to interpretation. It's subject to our individual tastes and preferences. And there are other variants on that theme available. For example, if you prefer a shorter, stronger drink, you might prefer a ristretto. If you prefer a longer, less intense drink perhaps, then there's alternatives available there. So the ratio might play some important role in allowing me to find a coffee that I like the flavour of. As well as the extraction ratio, something else that I found that appeared to be quite important is the density of the coffee bean that we're using. There's an entire website handily called Coffee Density, which is all about the important role that density plays and how we can use that density to find the perfect recipe for our espressos. So there's a few things here that seem to be quite prominent in how we can optimize our espressos. And this extraction idea is the one that I think is probably most important. So what I've got here is a quick video. And as this plays, I will talk you through the 4 phases of extraction, because as we are making an espresso here, what we're doing is we're forcing hot water at fairly high pressure through a puck of ground coffee. And as that happens, the first type of flavour to get extracted are the acidic flavours that the coffee releases. And this also brings through the caffeine as well. Once we get through the acids and the caffeines, the next thing to be extracted and released from the ground coffee are the oils and fats, and this gives the coffee a nice texture, a nice full-bodied flavour. Once the oils and fats have been extracted, then we're on to extracting the sugar. That's the next thing to be released from the ground coffee, and of course that sweetens the flavour of the espresso that we make. And then if we continue to force water through our ground coffee, what we're going to start to extract is perhaps the less pleasant plant extracts, which add this element of bitterness to the flavour of the coffee. Now the key here isn't necessarily to stop the second we've got to the sweet stage. The key here is balance. We want to have some sourness to the espresso to give it that sort of nice sharp edge to it, but equally we want a bit of bitterness to kind of round that off. And the key is to get it just right, not under extracted when it's going to be sour, not over extracted where it's going to be bitter. We want it right there in the middle. How do we achieve that? That's the tricky bit, isn't it? How do we achieve that? Well, one website I found, the Institute of Coffee, believe it's all about how we grind the coffee beans. If we grind the coffee beans really finely, that maximizes the surface area that the water is going to be exposed to, and it makes it very easy for the water to extract all of the flavors that the coffee beans contain. The danger there is if we grind it too finely, we might be over extracting too many flavors, including the bitter ones. So if we grind it too finely, we run the risk of over extracting our coffee. Alternatively, if we grind our coffee too coarsely, then we might under extract our coffee because we're not pulling out enough of the bitterness to round off the sour initial flavour. So grind size appears to be quite an important component of this, as well as various other things we'll see shortly. So what can I do within my kitchen? I'm doing all of this at home in my home lab. I've got a coffee grinder. I've got a tamper, which we use to kind of squash the coffee down. I've got a coffee machine, which has some buttons and dials on, which is going to be fun later. How do we use all this? How do we kind of optimize the process using this equipment? Well, let's have a look and find out. Okay, so hopefully that quick video there just gave you a sense of how I make my coffees. And as I went through that, I pointed out various aspects and things that I can vary in order to change how that coffee ends up tasting. I can change the type of coffee that I use. I can vary the dose weight, the amount of beans that I use. I can change the grind size that I grind the beans down to. I can vary the amount of force I use when tamping. I can change the temperature of my coffee machine. And I can also decide at what point I want to stop making the coffee. How much coffee do I want to produce? You'll see that with some previous experimentation, a bit of trial and error, I've identified a range for each fact that I want to look at. And so this is what I want to consider in my DOE study. So again, just a reminder, this is kind of my multi-stage process. I've got my coffee, my grinder, my tamper, my coffee machine. But actually, it's a little more complex than that, because this isn't really what I want to understand. What I really want to understand is this. It's not how do I get one coffee tasting good. It's how can I get any coffee tasting good? And that obviously becomes a slightly trickier question to answer. So how do we accommodate the varying coffee type? The obvious approach would be to treat the coffee type as a multi-level categoric factor. And if we say set that with 3 levels, we could set up our design to look at coffee type A, B, and C, which is great until we want our model to predict what coffee type D would taste like. Well, that's not going to be possible because obviously our design wouldn't have looked at coffee type D. So this sort of way of labeling factors in this categoric sense is always going to be somewhat limited. And I wanted to try and move away from that and find an alternative approach. So I thought that rather than labeling the coffee type just with the name of each coffee, instead, could I measure aspects, physical properties of each coffee bean in a way that allows me to quantify them and describe them and differentiate between them and so on. So that's kind of where my interest started to go. And I thought, well, what I want to do in my study is look at a combination of things. I want to look at things that I can't really control, but that I can only measure, so the properties of the beans. And combined with that, what I want to know is what can I do with my equipment to make the most of any coffee bean that I've got in front of me that I can measure the descriptors for. So what my design is going to need to do is combine these elements, the coffee and the process. And the goal is to develop a level of understanding where I can change my factors under my control, my grinder, tamper, and coffee machine, to accommodate the properties of any future bag of coffee that I choose to buy. So in sort of DOE terms, we're not thinking about these as separate things. What we're doing is kind of looking at the interaction between the properties of the coffee beans that I'm able to measure and the factors under my control that I can vary. This is obviously all very specific to me making espresso in the morning. Why should you care about this? Well, because I think this is a fairly general topic. It's not anything original, isn't anything that I've just invented, but I see there's lots of applications for this. If you're dealing with materials or ingredients or something that you can't really control, but you can only measure to assess, then maybe it would be useful for you to be able to set up a study similar to this one so that you can understand how to make the most of your raw materials by changing the factors that you are able to vary. And if we want to be very pretentious about this and throw some corporate buzzwords around, we can then claim that we've got an adaptable or responsive, or best of all, maybe an agile process that can be adapted to any new raw material ingredient. And of course, there's many application areas for this. Some of them listed here. But I think anyone who deals with variable raw materials, variable ingredients, may wish to think about this. Usually we assume with DOE that our start point is fixed. If we're buying a raw material in, we hope it's consistent. Well, I'm kind of looking at this the other way around. I'm saying, well, what happens if it's not consistent? What happens if it's highly variable? Why don't we embrace that? And say we want to get as varied a set of input materials as we possibly can, and see what our process can do to make the most of them. Now, to do this for my study, coming back to my coffees, what I need to try and do is get a big selection of coffees that capture every kind of extreme that we ever like to see in terms of the properties of the coffees, the tastes of the beans, and so on. Well, practically, I can't look at hundreds of different coffee types. What I need to do is carefully select a nice representative, diverse set of coffees that will kind of cover the entire multi-dimensional coffee space. Now, I don't know enough about coffees to know which beans to be choosing, so I spoke to this guy, Jack, at Coffee World. He's a head of coffee there, lovely fella. He was very helpful, and I explained to him what it was I was trying to achieve with my study. And between us, we then identified as to 6 coffees that we thought would give us a nice, diverse selection. So I bought some coffees, started to think about what I could do with these coffees, and of course some of the coffees are going to come from different places, Brazil, Colombia, Ethiopia, and so on. And those different coffee growing farms will use different types of coffee beans that they'll grow different varietals. So that might be another source of variation, be interesting to explore. How does the type of coffee affect the flavour? How are the coffee beans processed? How are they dried out, basically? There's a number of different processes that are used to dry the coffee beans out. And then how are the coffees roasted? Light roast, dark roast, somewhere in between. Again, all of these things are going to affect how the coffee tastes when I pour it into my cup and dry it. The trouble is, again, all of these terms are basically categorical labels. The origin is Brazil, or it's Colombia, or it's Ethiopia. So again, I'm kind of back to this problem that I want to avoid of having lots of categoric factors. There's a further problem, which is that if we treated these 4 factors, origin, varietal, process, roast, as categoric factors, it's likely that not every single combination of these things is going to be available. There's only so many bags of coffee on the shelf. We're not going to see every single combination of these factors at every single setting. So again, I want to move away from these categoric labels, and instead what I want to try and do is find out how I can describe these coffees numerically. Now, there's a lot of research and reading went into this, but ultimately, as I say, what I want to do is quantify the beans so that we can replace the labels, like a medium roast or a light medium roast or a medium light roast. How are they different? How are they similar? How different are they? Well, again, it's very difficult to say unless we can find some numbers to describe it. There is a limitation here, and that's me. I'm not a scientist. I'm not an analyst. I don't have a proper lab. I've just got my kitchen and a somewhat limited brain. So I'm going to have to try and be creative and imaginative here. And what we want to try and do is work out what can we measure for the chosen coffee beans that will describe them, differentiate between them, and ideally assess different underlying properties of the beans in front of me. So there was a lot of Googling, a lot of discussion with my contact at the Coffee World. And this is what I settled on as my list of things that I wanted to be able to include as factors. So I thought longitude, latitude, that's a good way to numerically describe where in the globe a coffee comes from. Altitude, well, that's obviously a nice easy number. How high is the farm where the coffee is grown? The density of the coffee, I mentioned there's that website, Coffee Density, that says density is really important. How strong, how tough are the individual beans? I noticed when I was handling them that some of them felt quite firm, others felt a bit softer. So I thought, well, maybe that's something that will prove to be influential on the flavour of the coffee. I noticed some of the coffee beans were much smaller than others. So again, I thought, well, maybe the size, maybe different varietals tend to be smaller or bigger, and maybe size is a good proxy for looking at different types of coffee beans in a numerical way. The colour of the beans, some of them are very dark, some of them are very light. So again, does that have an effect on the flavour? And the acidity, does that affect how the coffee tastes? The trouble is, at the start, I don't know whether these are actually assessing different fundamental aspects of the coffee beans. I don't know whether, if I measure all these things, they'll allow me to distinguish between my selected coffees. What I'm going to have to do is try them all and see what works. So this is what I did. When I arrived at my shortlisted set of descriptors, there are 8 numbers here that I want to be capturing for each of my coffee beans. And I realized, well, I've only got 6 coffees and 8 things I want to measure. So that's not likely to work out too well. So I doubled the size of my pool of beans, if you like. Rather than 6 coffees, I thought, well, let's push the boat out and go for 12. These are the 12 coffees that I ended up sampling. They're all listed here. You can see that they've got different names, obviously, different processes, how the beans are dried, how the beans are roasted, what varietals are used, as well as some tasting notes. So again, this is all text information, interesting, but not hugely useful in terms of what I want to do. So instead, let's try and quantify some things. So how does the geography affect the flavour and the behaviour of the beans? Well, the way that I assessed the geography of each coffee bag is I looked on the label on the front and saw where the coffee was made. I went onto Google Maps, clicked on it, and that gave me a longitude and latitude set of coordinates. So I've now got some numbers that describe where in the world this coffee comes from. This particular coffee, this Kenyan one, is a single origin, so all the beans in this bag come from one place. There are other coffees that I've got which are blends, so they come from multiple sources. So what I had to do in those instances is work out the longitude and latitude of each individual farm and then average them. So it's not ideal, but it may prove useful. The bags of coffee also tell me the altitude at which these beans were grown. And this one says it's 1,800 to 2,000 meters above sea level. So in the case where I've got a range of values, I just take the midpoint. So for this Kenyan one, I'd say this was grown at 1,900 meters above sea level. And this is what I found, that my coffees that I had in front of me were nicely geographically distributed across Central and South America, all the way over to Africa. What I also found is that one coffee farm is located somewhere in the Atlantic Ocean, just off the coast of Brazil. So that's probably not a very sensible thing to be, a sensible place to set up a farm. The reason why this coordinate appears here is because this is the average of 4 separate locations. This Blue Mountain coffee is blended from Brazilian, Colombian, Guatemalan, and Kenyan beans. And if you average those 4 latitude and longitude values, then you end up with wet feet. So clearly this approach isn't perfect, but I'm hoping it's going to be sufficient to allow me to kind of see any potential differences that exist. I mentioned before the coffee density website says that density is critical, so I went onto their website and followed their instructions on how to measure the density. It's very simple. You take a measuring cylinder, you put some beans in it, you measure the volume and the weight, and that gives you the numbers you need to calculate the density. I did that 5 times for each coffee bean so I can work out an average. And these were the results. Highly statistically significant differences in the density of my coffee beans. Now, I'm not going to spend long looking at the results for each of these things. I just want to quickly show you that there are differences here. Something else that I thought it would be interesting to measure is the strength of the coffee bean, the physical strength. How much force is required to crush an individual coffee bean using some scales. So what I did, very scientific, you can see this. I got a tamper and I squished the bean until eventually it crushes. And then I can watch the video back and see the exact force that was applied at the point that the bean crushed. Because this is obviously a very imprecise variable test that I'm doing, I thought I'd better do this lots of times. So I did it 10 times per coffee type. And I was actually quite surprised to see that despite the obvious variability within each coffee bean, the averages were statistically significantly different as you go from one type of coffee to another. So I was quite surprised at that. The size, again, could see this visually. Clearly, these beans are different sizes. So I wanted to quantify how different the sizes were. And rather than getting a number of coffee beans and measuring them by hand, I found a free app available online that's used to calculate particle size distributions of coffee, ground coffee actually, from a photograph. So I basically scattered some coffee beans on a piece of paper, put a ruler beside it. So I got a point of reference, took a photo, loaded it into the app, and the app then generated lots of measurements for all the coffee beans in each photograph. And again, there's a lot of variation in the bean size within each type of coffee, but the averages are statistically significantly different from one another as you go from a 1984 espresso to a Blue Mountain, for example. So there are, again, statistically significant differences here. Color. Again, something visually, you can see this. When you look at one coffee and another, one is often darker than the next. And in the coffee industry, there's something called the Agtron scale, which is used as kind of the industry standard for quantifying how roasted a coffee bean is. So I thought, brilliant, that's exactly what I need. Unfortunately, Agtron meters are quite expensive. And I thought, given that I'm doing all of this for today's talk, I don't really want to spend hundreds and hundreds and hundreds of pounds buying this gizmo. But I found a paper that basically said there is a very strong correlation between the Agtron score and the red component of a color if you measure it using an eyedrop on your computer and calculate the RGB value. So I figured, well, this is something I can do. Now, I like taking photos, so I've got camera gear sitting around at home. So what I did is I took photos of the ground coffee for each of my different coffee types. I calibrated the color to make sure it's nice and consistent. And I then basically did a color sampler across 9 different points in a 3x3 grid roughly, in order to estimate a number of different colour measurements. This point here, for example, the RGB score for that is 135 for the red component, 88 for the green, and 45 for blue. So the number here that I would be interested in is this 135. So I can generate 9 of these values per coffee type and compare them across the different coffee types. The only downside to this approach is that the higher the number is, that's basically indicating a lighter colour, whereas I was hoping, and I should have thought about this a bit more carefully at the start, that the higher number would indicate a greater level of roast, so a darker roast, whereas in fact there's a negative correlation between the measured colour number and the amount of roasting. So a high value is a light roast, a low number is a dark roast. So there was a slight error on my part when calculating this value, but there we go. It's still a valuable measure of how roasted these things are. And we can see, again, statistically significant differences in the colour between each of my 12 coffee types. Finally, acidity is a term that's often used when describing the flavour of espressos. So I thought, well, obviously, this is something I want to measure. And so what I did is I ground some coffee, tried to dissolve it in boiling water, measured it multiple times per coffee type, using a very cheap pH meter, a £5 from Amazon, this one, so not quite lab grade equipment. And despite the limitations of my dirt cheap equipment, I still saw statistically significant differences in pH as well. So I was genuinely shocked that with such limited equipment and such a limited scientist, I was able to see statistically significant differences in the pH levels of the beans that I was using to make my coffee from. So, to summarise, every descriptor that I measured turned out to show statistically significant differences amongst the different coffee types, which I have to say I was genuinely shocked at. I thought some of them probably would allow me to differentiate between the beans and others probably wouldn't. But having seen these results, I've decided that I keep saying I'm not a proper scientist. Well, I've actually generated an AI picture of myself in a lab coat because I think I deserve this now after doing this hard scientific work and producing useful results. I think that's the least I deserve. Well, maybe not the least. Maybe I deserve a gold star too. So I've generated lots of measurements now. I've seen that the measurements allow us to detect differences from one coffee type to another. My next question was, well, are these measuring kind of independent properties of the beans, or am I just measuring the same fundamental thing many times, just in slightly different ways? So what I thought I would do is use principal components analysis to see how similar or how different the various measurements are. Now, Design Expert and Statis 360 do not offer PCA analysis as part of the standard toolkit yet. Maybe that'll be a future version, hint, hint. But what Statis 360 does allow us to do is add some Python code of our own concoction to extend the functionality. So that's exactly what I did. I wrote some Python code to perform a principal components analysis within the Statis 360 environment. I mean, I say I wrote the code, I borrowed the code from this website here, but it's same principle. And when I ran this code, this is what it produced. And what this principal components output shows us is on the left, these are what are called the scores for each individual bean. And this allows us to see how similar or how different the different types of coffee are. On the right, this is called a loadings plot. And what this shows is how similar or how different the things that I'm measuring are. And what I was really pleasantly surprised to see here is that all these arrows are kind of pointing in different directions. Now, it's all relative, but still, the fact they're all pointing off in different directions, that was enough to convince me that what I wanted to believe was right, which is that these are actually measuring different attributes. And it's going to be interesting to continue to measure these and use these different factors, these different descriptors, I should say, in my study. So I was very pleased. So far everything's going amazingly well, much to my surprise. And so the final thing I wanted to do is just check that I can measure these things. If I try to build a model from them, can I actually predict, or sorry, can I model all 8 descriptors? And when I tried looking at this in the evaluation tool in Design Expert, what it showed me is that if I try and fit a model that involves all 8 descriptors, then a couple of them have quite high VIF numbers. And what Design Expert basically says is we want the VIFs to be low. If the VIFs are too high, then that's a potential cause for concern. It may be there's too much multicollinearity in our design. And I can see here that the rule of thumb here is we don't want it to be above 10. And I can see that a couple of these ones for factors D and E are at or just above 10. So with a little tinkering, a little trial and error, what I found is if I just remove factor D, which is the crush force factor, then all the remaining VIFs drop down much, much lower. So if I accept that I can't really assess crush force as part of my analysis, then that felt like a pretty good sort of trade-off to me. I won't have to estimate and assess the crush force for all my coffee beans. It reduces the number of factors slightly, and it gives me a better chance of understanding the effects of the remaining 7 descriptors. So I sacrificed crush force in order to be able to estimate the other 7 descriptors as well as possible. So here they are. Here are my descriptors. When it came to the other side of things, the responses, well, the obvious thing to measure here is taste. How do we assess taste? Well, it's difficult because it's completely subjective. It's me making coffee, me tasting the coffee. It's going to be very biased, very subjective. So one possible solution would be to use a tasting panel. But unfortunately, I'm doing this study at home. So my options are, there's me, there's my wife, who doesn't drink coffee, and there are my 2 children. But this is what they're like normally. I figured if you add caffeine to this, it's not going to end well. So I ruled out that option and accepted that in this study, it's going to be subjective. I'm going to have to accept that. It's not ideal, but given that the purpose of the study is to make coffees that I like, maybe it's not the end of the world. I can also see if there are other things that I could measure alongside that to allow me to assess things more objectively and potentially build more robust models. And it may be I have to accept that not all the responses that I measure are going to be predictable. My taste it's going to be very variable from one day to the next. And it may be that I have to accept that the model I get for my predicted taste is not great. But does that really matter? The purpose of this study is to help me understand the process better. And if this study allows me to do that, then perhaps that's just as important. As George Box famously said, we all know this line, don't we? All models are wrong, but if my design allows me to understand the process better, it's served its purpose. So in terms of tasting the coffees, I had 2 taste responses. One is the overall taste, 0 to 100, 100 being perfect, 0 being awful. I also thought of a different way of measuring taste, which is on more of a continuum, so sort of a Goldilocks scale. And what I'm looking at here is whether it's either very sour or very bitter. So we're kind of going on this continuous scale. If the coffee tastes just right, if the extraction is right on the money, then I would give the taste balance score a value of 0. If it's very sour, I'll give it a high negative value. If it's very bitter, I'll give it a high positive value. And I thought this might move me slightly away from the actual taste of the coffee bean itself. All I'm trying to assess here is, have I extracted this particular coffee about right or not? Alongside that, I looked at some more objective measurements, and they're called TDS, which is total dissolved solid, measured via a refractometer. From that, you can also calculate something called the extraction yield, which basically asks the question, how much of the coffee that I ground has ended up in the drink that I'm now drinking? And what's useful about this one is there's a range of typical values that we'd expect to get for espressos, somewhere around about 20%. If the number is much less than that, then that's an indication it's going to be quite sour. Much more than that, it could be quite bitter. So I thought this might be a useful objective measure of extraction. There were also a few other things I recorded as well along the way. I wasn't so interested in these, but I thought I'm writing them down anyway. I might as well record them and try and analyse them later. So when it came to the design of the study, I actually planned to do this in 2 steps. Initially, I thought I'm going to do a screening study and then an optimization study. So initially, I set up a 30-run screening design to assess the main effects of my coffee descriptors and the process factors. hoping that I was going to be able to reduce down from 7 descriptors and 5 factors to a more manageable number, but unfortunately that didn't pan out in that way. Everything turned out to be statistically significant. So this study was unfortunately a complete waste of time. So I'm not going to talk about the screening study today, but I did set it up in exactly the same way as the optimization one I'm going to show you now. I considered augmenting to go from my screening to my optimization, but there's a few other changes I wanted to make as well. I wanted to get rid of one of the coffees because I just really didn't like it. I wanted to change some factor ranges. So I thought it's going to be cleanest and simplest to start with a fresh design. So across the two studies, I'm basically making and tasting 120 espressos, and it takes about 5 minutes to make each one. So that is a total time of 10 hours I've spent just solidly standing in front of my coffee machine, making and drinking coffee. So quite a lot of time's gone into this. So again, what we're trying to do here is look at the interactions between our descriptors and our process factors. The best way I thought to do this would be to use an optimal design. They're very flexible, very powerful, and they allow us to ensure that every run we are to do is something that we can do. So I thought, well, the optimal design is the obvious choice here. And what I did is I set this up using a candidate list. So this method, we've presented this sort of method at previous talks, so I won't go through it in great detail today, but the idea is that we first of all set up all the combinations of the process factors that we can actually perform. So these are things like dose weight, temp force, and so on. That generates 405 combinations that we are happy to run. And I then manually build up the design, those 405 runs for each of my chosen 11 coffee types. So that gives me about 4,500 different coffees that I basically am saying that I could make these. I don't want to make 4,500. What I'm going to do is import those possible runs back into Design Expert, generate something called a candidate file, and then load that into the optimal design builder. And what this will then do is ensure that every single run that Design Expert asks me to carry out is one that I've already told it, I'm happy to do this. I'm capable of running this experiment at these factor settings. Once we've loaded in the candidate list, we can then specify the type of model we want to fit. We can then review the number of runs and decide whether or not we want to block our experiment. We then review the design, and if we're happy with it, off we go to our lab, or in my case, my kitchen, and start drinking coffee. So to try and optimize my experimental workflow, I thought it'd be pretty slick to develop my own electronic lab notebook. Now, what I did is I used something called Airtable, which is an online spreadsheet database tool. Some of you may know of it already. But I thought if I put my design into Airtable, then what I can do is basically carry my phone into the kitchen with me and have all the data I need in front of me. So this is telling me on any given day, it gives me a filtered list of these are the coffees I've got to make today. And I can then click into any one of those and see exactly how I need to set up my coffee machine and tamper and grinder, etc. I can then feed in the data as I generate it, making it really easy to sort of capture this and carry out the study. So this was actually a really nice little solution I stumbled across. In terms of the analysis, it's going to be tight, isn't it? Here is a nice picture which shows where the best coffees are. On the horizontal axis here, we've got the taste balance. So on the left, very sour. On the right, very bitter. In the middle, just right. Near the top, these are the ones that I've rated as having the highest taste score. And I spotted straight away, there's this obvious sort of triangular shape to this, which kind of makes sense. Because if something is very sour or very bitter, I'm likely to rank it quite lowly in terms of its overall flavour. The ones I like the look of are these ones up here at the top. These are ones where the extraction balance is about right, not too sour, not too bitter, and I like the overall flavour. So these are the ones that I want to kind of understand best. In terms of the analysis, I set the study up to be blocked across 15 days. It turned out that the block effect wasn't significant, so I ignored it. I used Design Expert's auto select tool with the AICC or p-value criteria with a bit of manual review to check models were sensible. Where recommended, I applied transformations to my responses. And this is the summary of all of my responses, along with some of the key metrics from the analysis summary tool in Design Expert. And I have to say, again, I was really surprised. Some of these models, the R-squared metrics are really strong. R-squared adjusted, R-squared predicted, R-squared were all a lot better than I was expecting. Now, my overall taste response here at the end, this is me going, how much do I like it, 0 to 100%? It's not a great model. It's not particularly predictive, but I wasn't expecting it to be. This is about as good as I was hoping for. And as well as the R-squared metrics, the other statistics I look at here, they all appear to be pretty strong. So I was really quite pleased that the results were as nice as they were. And it allows me to kind of drill down and understand things better. So my overall taste response, here's the model I arrived at. I noticed that the average taste was pretty much exactly 50%, which I thought, that's perfect. That's exactly where it should be. So again, I was surprised it turned out that way. It wasn't perfectly normally distributed, but you can't have everything. And looking at the predicted versus actual plot, this isn't bad. Considering this is just me tasting a coffee and going, how much do I like it? That was a lot better than I thought it would be. In terms of actually understanding how can I make the most of my coffee, this profiler graph gives me kind of a high-level view of how each factor individually affects my overall taste perception. But what's probably more interesting still is to kind of drill down into a bit more detail. And let's say, for example, we've measured the density of a coffee bean. It turns out that I prefer less dense coffee. Don't quite know what that means, but it turns out that if my coffee is less dense, I'm likely to enjoy it more. But I can't control the density. I can only measure it. But you'll see at the top here, it points out that density is involved in multiple interactions, and here's one of them. Density by brew temperature. That's something I can control. I just press a button on my machine to ramp the temperature up or reduce it. And so depending on what my measured density is, I can choose different parts from this contour plot simply by adjusting the brew temperature to try and improve the flavor for the density I've measured. And it makes a big difference. These four corners of this contour plot, there's a swing of 20+% in terms of improving the flavor. So once I've measured the density, I can control my process. I can adjust the temperature to make that density coffee taste as good as possible. I can also consider, if I go for a higher temperature at the back of this graph, that's a much flatter profile than it is at the front. So if I go for higher temperatures, the effective density is minimized. So again, maybe I can make my taste response more robust to change in density by ramping up the temperature. We can do the same for the taste balance response and look at the surface area. Again, we can't control this, we can only measure it. But depending on the measured surface area, we can play with the tamp force, how hard we squish our coffee down to try and get the balance of the flavor just how we like it. So again, these interactions really get to the heart of what I was trying to achieve with this study. How are we doing for time? We're about to run out, aren't we? So it all comes down to making the best espresso. I can use the numerical optimization tool, but this is going to let Design Expert choose any values it likes for longitude, latitude, etc. And that's not really sensible. What I need to do is tell Design Expert what the altitude or longitude or latitude, whatever it is of the coffee I have in front of me. So if I've got a Kenyan coffee, then I need to tell Design Expert the altitude must be 1900 meters. Now, I'm sure lots of people have done this before, but I'm naming and claiming this. I'm going to call this McPherson conditional optimization because I developed a Python tool to make this really easy to apply. So with, again, Stat-E360's Python integration, I create a little dialog that made it really easy for me to dial in the settings for any of my coffees, and then Design Expert could tell me how I could set my brew temperature, tamp force, etc. to make the most of that individual blend. Now, in the interest of time, I am running a little bit behind, so I'll just skip the verification, but I did do some verification runs and they were actually really good, surprisingly good. To conclude, because I'm running late and I do apologize, DOE allowed me to do a very complex study that would otherwise have been utterly impossible for me. It gave me all the tools I needed to explore the coffee descriptors combined with the process factors, allowing me to really get every last drop of goodness out of my coffee beans. it was genuinely surprisingly good in terms of how predictive the models were that Design Expert gave me. And what I learned doing all this is that actually teaching DOE is pretty straightforward. The hard part turns out to be the science. Who knew? What I found, though, is genuinely really interesting that I got so much more out of the research and the planning than I did from the study itself. I feel I got more information out of looking at the process in detail, and all DOE really did was it gave me a structure to explore it properly. So I think this is a point worth repeating. It's a point we make often. DOE is just there to help the scientist, not to replace the expertise. The other thing I discovered is when you're doing lots of DOE work, caffeine's good. So that's pretty much it. I do apologise I've not left time for questions. So if you do have any questions you would like to ask about this presentation, please drop us a line. There's a QR code and a link there. If you go to that, it will give you a link to our contact forms. You can ping a question to me directly. If you'd like to see any future articles or anything on this coffee, please drop me a line. We will be publishing articles on this on our website soon. If you would like to be notified about those articles when they're published, please sign up to our mailing list. If you do, you will also receive an exclusive 25-year anniversary offer that's going to be sent out this Friday. So if you want to receive information on a training discount to celebrate our 25th birthday, subscribe to our mailing list before Friday and you'll get that email coming through to you then. Okay. Thank you very much. I apologise that it's been a bit of a whistle-stop tour through this study. Thank you very much to everyone whose work I have stolen and passed off as my own in terms of today's talk. Thank you very much, my friend at Coffee World. He's been extremely helpful in helping me to understand what this study needs to do to succeed. Thank you to my colleagues who've listened to me prattle on about coffee for the last 4 or 5 months. And thank you very much to Statis for inviting me to talk today and providing us with such great software. Finally, thank you for watching. I hope you found it useful. If there are any questions, we probably don't have time to take them now, so please do feel free to drop us an email. I hope you found today's talk useful. Thank you.
Thank you very much, Andrew. That was a very enlightening presentation, and I'm more of a tea person myself, but now I might get interested in coffee. All of the details very much reminds me of the differences between green and black and oolong. It's very, very applicable across beverages and across industries. There was one question about whether or not the handouts and the video will be available. The answer is yes. We do have slides, and there will be a video that goes up on our YouTube channel, hopefully later today, possibly later this week. And if you are subscribed to Statis' newsletters, you will get one of those about when the recordings are available for the summit. So again, thank you, Andrew.
Yeah, thanks, Andrew, for that really great talk. I love coffee. I was actually grinding and making some coffee at the beginning of your talk there, being kind of early in the morning here in Minnesota. So yeah, that was really cool to see. I remember our coffee experiment, which, like you said, was a split plot. That was with the when that was a new feature in version 9. And I thought it was interesting when you were talking about having a taste panel, because that experiment we had to make, I want to say 75 pots of coffee in order to estimate all the different factors that we had. And we had a panel of 5 people, and we only did one pot of coffee at a time. So with vacations and work trips and whatnot, that was actually really probably the most difficult part of that experiment. But that was fun. I love coffee, and it was neat to experiment with. I still haven't. I got to go buy some of the beans that we decided was the ideal cup of coffee, and make that again sometime. So thanks for that. I also really like the Python part of it. I'm going to be doing a little bit of Python in my talk as well, so that's always great to see.